When geneticists sequence the DNA of modern Levantine and global Jewish populations, they identify a substantial genetic signature linking these groups to a completely different geographic zone, the rugged, snow-capped peaks of the Caucasus Mountains. Historians frequently attribute this northern genetic link to recent medieval events. The most prominent explanation involves the Khazarian hypothesis, a large-scale conversion of Turkic peoples in the 8th century. Paleogenomics places the origin of this Caucasus signature 4,000 years in the past, establishing it as the foundational bedrock of the region's ancestry. Tracing this lineage back to its source reveals the specific mechanics of Middle Eastern ethnogenesis. The primary setting for this event is the early Bronze Age Levant, around 3000 BCE. This was a landscape defined by emerging, competitive city-states and agricultural wealth. Thousands of miles to the north, a different society was forming. The Kura-Araxes cultural tradition emerged in a highland geography defined by isolation and highly specialized survival strategies. A multi-generational migration from these highlands moved southward into the Levant, shifting the genomic and cultural makeup of the local population. Proving a prehistoric migration requires layering 3 independent scientific datasets: the physical artifacts of archaeology, the historical evolution of linguistics, and the data of ancient DNA. Any single piece of evidence could simply point to trade or stylistic imitation. Triangulating all 3 fields is the only way to demonstrate a physical human migration. The first layer of evidence appears in the archaeological record around 2850 BCE. A foreign material culture abruptly surfaces in the northern valleys of the Levant. This visualization contrasts the 2 primary ceramic styles found at these sites. On one side, we have the established local Canaanite pottery, light-colored and wheel-made. On the other side is the sudden arrival, a handmade red and black burnished ceramic known as Khirbet Kerak Ware. This creates an archaeological debate over whether local populations simply imported these striking vessels or if a new population physically carried the items with them. To find out, material scientists use petrographic analysis, a method that examines the microscopic mineral composition of the clay to identify its geographic origin. The petrographic results show that the clay used to create Khirbet Kerak Ware was strictly local to the Levant. The vessels were made on site, ruling out long-distance trade imports from the Caucasus. Next, researchers apply radiographic analysis to the pottery. X-ray imaging allows them to observe the operational sequence of manufacturing, the specific physical habits of the potter. This cross-section diagram shows mechanical stress lines. Wheel-thrown local pottery displays uniform, parallel alignment. Khirbet Kerak Ware reveals irregular, layered lines, identifying its manufacturing as foreign. These potters utilized a labor-intensive hand-coiling technique, rejecting the efficient Canaanite wheel used by neighbors. Local artisans imitating a trend would use their own, more efficient tools. The preservation of a labor-intensive foreign manufacturing method using local materials demonstrates the physical, resident presence of migrant artisans. Khirbet Kerak Ware arrives as part of a comprehensive cultural package that changed the basics of domestic life in these settlements. Excavations reveal sharp architectural shifts, replacing mud brick with wattle and daub housing. Faunal remains show distinct butchery patterns, optimized for stews on horseshoe-shaped anderns. These communities also introduced a specialized technological shift, the mastery of arsenical bronze metallurgy, forging tools with polymetallic ores. Chemical analysis of early metal artifacts in the region shows these ores were sourced directly from the Caucasus. These are the intimate routines of building homes, preparing meals, and fabricating tools. Changes at this level demonstrate that the migration consisted of entire households moving together, rather than a small elite military class. While the archaeological record confirms the physical presence of families, historical linguistics identifies the population. The Hurrian language family is a linguistic isolate with no structural roots in the dominant Semitic or Indo-European languages of the region. Its only known geographic origin point is the mountainous zone of the South Caucasus and eastern Anatolia. By the Middle and Late Bronze Age, Hurrian personal names appear densely across Levantine texts, representing individuals at every tier of society, from merchants to kings. There is a chronological gap here. The Kura-Araxes archaeological presence ends around 2500 BCE, but the explosion of Hurrian text records does not occur until 2000 BCE. Excavations at the ancient city of Urkesh in northern Syria address this gap. Urkesh contains early Hurrian urban centers dating back to the 3rd millennium BCE, showing direct interaction with Kura-Araxes groups. This establishes a linguistic substrate. The early Bronze Age migration planted a Proto-Hurrian speaking population in the Levant. They survived as a minority demographic for centuries, only becoming visible when the bureaucratic records of later empires finally documented them. Archaeology identifies the artifacts, and linguistics identifies the people. Ancient DNA provides the quantifiable evidence of demographic scale. Prior to the Bronze Age, indigenous Levantine populations shared a stable genetic profile, classified as Levant N. Thousands of miles away, the ancient populations of the South Caucasus carried a different profile, characterized by Caucasus Hunter-Gatherer and Neolithic Iranian ancestry. These admixture pie charts map genome-wide data extracted from Bronze Age Canaanite burials. The local Levant N baseline shrinks abruptly as it accommodates an influx of Caucasus and Iranian-related ancestry. This shift accounts for approximately 50% of the region's total genomic ancestry. This decaying waveform tracks linkage disequilibrium. When populations mix, they pass down long DNA blocks. Each generation, blocks break into smaller pieces, allowing geneticists to calculate the initial mixture. This decay dates the gene flow between 4600 and 1550 BCE, encompassing the Kura-Araxes expansion. Specific Y-DNA markers, notably haplogroups J2 and G2A, appear in both Kura-Araxes skeletons in the Caucasus and Bronze Age Levantines, confirming the exact vector of the gene flow. The genetic data aligns with the archaeological and linguistic record. The Canaanite people emerged as a hybridized population within the Kura-Araxes expansion window. Synthesizing this evidence reveals the character of the migration. The lack of destruction layers at local sites indicates a protracted infiltration rather than a sudden military invasion. The migration followed a network-based model. Small, kin-based pioneer networks established isolated enclaves, facilitating the movement of subsequent groups over generations. This movement was driven by the economic collapse of the Uruk network in the north and the demand for specialized metallurgical skills in the urbanizing Levantine city-states. The Kura-Araxes migrants integrated over centuries, culturally and genetically fusing with the local population to weave a northern element into Levantine ethnogenesis. This Bronze Age genetic hybridization has proven remarkably stable, persisting to the present day. Contemporary Lebanese, Palestinian, and Syrian populations derive up to 93% of their total ancestry directly from this hybridized Bronze Age gene pool. This genetic baseline extends to global Jewish diaspora populations, whose foundational ancestry is rooted in this same ancient Levantine admixture. This data provides a resolution to the Khazarian hypothesis debate. The presence of Caucasus ancestry in modern Jewish populations reflects the persistence of this 4,000-year-old Bronze Age signal, a legacy shared by all descendants of the ancient Levant. Modern demographic identity is the result of ancient, large-scale migrations that formed the genetic bedrock of the region.